a bit more introductory part to exponents. So we are looking at revising what we learned. 3 into 3 into 3, that is 3 cube. Minus 3 into minus 3, minus 3 cube. Minus 3 the whole cube. A into A cube. A into A square into B square. A bit tricky one. 4 into 4 into 4 into 4. So 4 to the power of 4 into 3 into 3, 3 square. Minus 5 3 times. Minus 5 the whole cube into 6 into 6, 6 square. Right? So this is what we learned in the last video. A bit more variation, and as usual, every step we learn something new. So here I have 3 into I don't know how many lakhs this is. So this is right. So many crore or so. Is it not? 1000 crore, 10 crore. So how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros are there. So how do you write this? Well, this can be written as 3 into 10 into 10. So this will be 8 times. Is it not? So I can write this as 3 into 10 to the power of 8. Let me make some space because I'm not happy with the space. Okay, now I'm happy. So basically I can write this as 3 into 10 into 10 into 10 into 10 4 times, 5th, 6th, 7th and 8th. So we have 3 into 10 to the power of how many times? 8 times. This is nothing but the approximate value of speed of light. See, this is so difficult to read and understand. While this, you can understand this particular representation using exponents. You can understand very easily, and it's easy to talk to someone or discuss with someone. Make sense? Next number, 4.64 divided by 1, 2, 3, 4, 5, 6. That is 10 into 10 into 10. How many times? 6 times. This is nothing but 4.64 into 10 to the power of, no sorry, it's in the denominator, right? Divided by 10 to the power of 6. Okay, this I just wrote it. This I didn't mean to represent anything. If it means something out there, I didn't mean that. I just wrote it. Next one is 4 into 4 into 4 in the numerator. So that 4 to the power of 4 divided by 3 into 3 into 3, 3 cube. Right. So we have our exponents. So we're looking at a few more variations so that we understand the concept better. Again, my request is, as usual, what is my request? Any guess? Yes, please pause the video before you watch my recording. So now, 4 into 10 into 3 square is to be compared with 4 into 3 the whole square. So let's solve this, the left part first. So 4 into 3 square is 3 into 3, which is nothing but 9. 9 3 is a 36. What does this mean? Again, pause it. If you're not done it, please pause it and try it out. 4 into 3 the whole square, it is 4 into 3 into 4 into 3. So 4 into 3 is 12. 4 into 3 is 12 again. Again, I could have multiplied it anyhow, but I chose to multiply this way. 12 into 12 is 144. So clearly, this is a scenario, right? Left hand side is lesser than the right hand side. Again, try the questions. Don't watch just before trying. Don't watch it. Do try it, then watch it. So here on the left hand side we're looking at 6 into 4 into 4, right? And on the right hand side we are looking at 6 into 4 into 6 into 4. I need not even calculate. It's very clear that my right hand side is bigger than the left hand side. Okay, the question is which is bigger? I need not calculate it. First one I did, but second one I didn't, because again the question is which is bigger. Doesn't matter what the final answer is. So if this was an MCQ question, I would have got 100% for this question. Next problem. 4 to the power of 0. What is 4 to the power of 0 or something to the power of 0? 1. 4 to the power of 1 is 4. Clearly, again, right hand side is bigger. Next question. Minus 10 to the power of 0 is minus 1, while 10 to the power of 0 is 1. Is this correct? No. Minus 10 to the power of 0 is plus 1, so both are equal. Got it? So we are looking at negative exponents. This is the tough part. Right? So negative anywhere is tough. So what does it mean? Whenever you come across any number or variable whose power is negative, all you have to do is take the multiplicative inverse of that number and keep the power as it is by changing the sign. Again, I'll repeat, first we'll take multiplicative inverse, right, plus multiplicative inverse of the base. See, if you know the language, this will make sense. Change the sign of the power. Okay, so what does it mean? I know you need not by heart this, I just wrote it. So this means that what is the multiplicative inverse of 4? 1 by 4, right? So 4 to the power of minus 2 is 1 by 4. Minus 2, I have to change the sign. So if I have to change negative 2, what is the other sign? Positive. So positive 2. That's it. Make sense? It's just a representation. Actually, it need not make sense as of now. It's just a representation. All are this representation. Got it? All these are just representation. Don't think too much into it. So 6 to the power of minus 10. That's how you read that as. So first step is find the multiplicative inverse of 6. That is 6 can be written as 6 by 1. So 1 by 6. Substitute it over there. So this will be 1 by 6 to the power of minus 10. Minus 10 will become plus 10. Okay. So your question might be, sir, what if I have a positive term? Can I do the same thing and change the sign? Yes, you can. So maybe some point of time we will make use of it. As of now, I don't want to confuse anyone. So if you got what I said, good. If not, it's okay. I'll show you with example in time. So next question is 3 by 8 to the power of minus 6. First step is find the multiplicative inverse of 3 by a. What is it? Simple, a by 3. Next step, I just have to write a by 3 whole to the power of, change the sign, 6. Quite simple. What is the multiplicative inverse of 4a by b? That is b by 4a. And now all I have to do is b by 4a to the power of plus 10. Okay, so remember this part, it's not too hard, but still remember it. Now I have a complicated comparison. So I need to compare minus 4 to the power of 2 and minus 4, negative 4 to the power of negative 2. I need to compare which is greater and which is smaller. So again, let's start. Minus 4 square is to do with minus 4 into minus 4. Negative into negative is positive. 4 into 4 is 16. Minus 4 whole to the power of negative 2. So first is, it's like a confusing part, what to do first. Should I handle the negative of the power first or the bracket, inside the bracket? Actually, you can handle anything, but as of now, I think it will be better that we handle the powers negative. So if I have to deal with the negative in the power, I have to find the multiplicative inverse of negative 4. What is it? Negative 1 by 4. That if I substitute it over there, negative 1 by 4 whole square, I need to change the sign. So this means negative 1 by 4 into negative 1 by 4, which is positive 1 by 16. Yes, clearly the left hand side is bigger than the right hand side, but you can see the math. Just a small change in representation and it will show you a different number altogether. So that's what they wanted to do and that's what they got, right? It's just a representation, remember. Instead of writing 1 by 16, they have written this and this is one and the same. Okay, so let's try out the next problem. So first I'll do negative 1 by 4 to the power of negative 2. So first thing is we'll handle the power by finding the multiplicative inverse of negative 4 by 3. That will be negative 3 by 4. Next is I need to substitute it over there. So this will be negative 3 by 4. I should change the sign of the power to square. So negative 3 by 4 into negative 3 by 4. Negative into negative is positive. 3 into 3 is 9. 4 into 4 is 16. Next one is negative 4 by 3 the whole square. So here there's no complicated thing about multiplicative inverse. There's no complication, but still there is a negative inside the bracket, so I need to handle it carefully. Negative into negative is positive. 4 into 4 is 16. 3 into 3 is 9. Actually, if we need to compare this, I need to make the denominator same. LCM needs to be same and all of those, right? So for now, I'm going to just let it be. Main thing was to compare the main idea was to make you guys get used to the idea of negative exponents and negative terms. Okay, this is kind of homework, I guess. So if you guys want to do this and post it in our blog or some kind of futuristic, I don't know, whatever it might be, you guys can do that. But yes, this is my first homework, I guess. Literally, no guess, this is my first homework. Okay, good luck with your test and see you guys in the law part of exponent. I have 2 more problems, so let's look at it. The first one is 2 square plus 2 to the power of negative 2. So 2 square is 2 into 2 plus this part. Okay, let us handle that part first. So we're looking at, again, maths can be done part by part. So we're looking at 2 to the power of negative 2. So for that I need to find the multiplicative inverse of 2. That is 1 by 2. So if I substitute that, the negative power goes away and we have 1 by 2 into 1 by 2, which is nothing but 1 by 4. Make sense? Now let's substitute it back into the question. So 2 square plus 2 to the power of negative 2 is nothing but 2 square plus 1 by 4. Okay, so in place of this, which I calculated, I'm writing it as 1 by 4. So we have 2 square as 4 plus 1 by 4, and if you want to take LCM and all of those, if you take that, we'll get 17 by 4. Okay, you can try it out. You can take the LCM and all of those. Fraction addition, which we have done, a lot of problems has been done. So I'm going to write it directly. The next one, the last one. This is for sure, this is the last one. Solution. We have, I'll take the first term and the second term, I'll do it separately so that we can substitute it and things will become much simpler. So here I have to find the multiplicative inverse of 3, which is nothing but 1 by 3. So 3 to the power of negative 2 will be 1 by 3 whole to the power of positive 2, which is nothing but 1 by 3 into 1 by 3, which is nothing but 1 into 1 is 1, 3 into 3 is 9. So let's do the second part, that is 4 square by 3 square, which is nothing but, see, 4 square in the numerator is 4 into 4 divided by 3 square is 3 into 3. So this is nothing but your 16 by 9. So now let's copy the question and substitute all of this. So 4 square by 3 square minus 3 to the power of minus 2. So this is 16 by 9 minus 1 by 9. So LCM is 9, difference is 15, 15 by 9. Okay, now we are done.